Hello class, welcome to Unit 5, Lesson 5. Today we're going to be solving system of equations using algebra. So that means elimination or substitution. You might be thinking this is a bit odd because all of Chapter 5 we've been dealing with matrices. And so with our matrices we've been learning how to add, subtract, multiply, find their determinant, and the inverse. Another cool thing that matrices can do is it can help solve a system of equations. But before we dive into what the matrices or how to solve them with matrices, I want to show you how, or remind you how, we can solve system of equations with algebra. So using elimination or substitution. So your goal or learning target for today is that you will solve a system of equations. We're going to do 2 variable and 3 variable using elimination or substitution. Okay, so our first example, it says solve the system. It tells me specifically to do so using elimination. Whenever we're using elimination, we want to go ahead and eliminate one of the variables, either x or y. I always try and pick the easier variable. And your goal to eliminate is to make one a positive number and then the other variable to be the exact same number but the negative value. So when I add them together, I get 0. Okay. So right now, I would agree that getting rid of my y's is the easiest because they're both already 2's. So what I'm going to do is take this bottom equation times a negative 1. Okay. So rewriting the top equation. And now my bottom one, I'm going to multiply everybody by negative 1. Now my goal is when I add the 2 equations together, I will eliminate one of them, one of the variables, and I will here. The y's will be eliminated. So here I am left with 2x equals 8. And if I solve for solve for x, I would divide both sides by 2. I get x is equal to 4. Now in order to solve my system, I need to know what x is and y is. So I'm going to take 4 and plug it into either one of these equations. It does not matter which one. I'm going to go ahead and use the top one. So I would have 4 times my x value, which is now 4, plus 2y equals 15. This is 16. I would then subtract 16 from both sides. So I have 15 minus 16, so negative 1. And then when I divide by 2, I get y equals negative 1/2. So my solution for my system of equations is 4 comma negative 1/2. That kind of got a little crowded there. Always write our answers as ordered pairs. And so here is the first one. Okay, there is my example with elimination. Take a second, pause the video and give this one a try on your own, and then come on back and I will solve it for you. Okay, so hopefully if you solve this, you got an answer. I think the answer should be 5, 2. So let's check it out. So which variable shall we eliminate? We got our x's and our y's. Neither one are exactly the same number. So what I'm going to do is I'm going to eliminate x's. Okay. And what number can I make 2 and 3 both multiply to be? I can make them both multiply to be the number 6. Okay. So I'm going to take the top equation times 3. Then I would need to take my bottom equation. I'm going to take it times negative 2 because I want a negative 6 down here. So I multiply everybody by 3 on the top one. So I'm going to rewrite it. So I would have 6x plus 12y equals 54. Then I have negative 6x plus 12y equals negative 6. Okay. When I go ahead and add the 2, if I've done elimination correctly, one of the variables will cancel, in this case my x's will. So I'm left with 24y equals 48. And when I divide both sides by 24, I get 2. So y is equal to 2. Now I'm going to take y, plug it into one of my originals, and solve for x. Let's go with the top equation. You could pick either one. So I got 2x plus 4 times 2 equals 18. So I got 2x plus 8 equals 18. Subtract 8 from both sides. I get 10, and when I divide by 2, I get x is equal to 5. And then I always write my answer as an ordered pair, so it is x comma y, which would be 5 comma 2. So if you got that all on your own, nice job. All right. Another system of two equations, we are going to solve it using substitution. Directions say use substitution. So that means we want to get one variable by itself and then sub it in to the other equation for that variable. Okay. It looks like y is easy to get by itself in both of these equations. I'm going to take the bottom one. Okay, to get y by itself, I would move the 4x to the other side. It's currently a positive 4x, so I would subtract it. So y equals negative 4x plus 4. Now I will go ahead and sub what y is equal to into the other equation. So I have 5x plus negative 4x plus 4 equals 10. Okay. Combining my like terms, this gives me x plus 4 equals 10. And then if I subtract 4, x equals 6. Now in order to figure out what y is, I plug it into one of my two original. I could plug it into actually y by itself, my simplified one. So I'm going to do that. Y equals negative 4 times 6 plus 4. So what I got? Negative 24 plus 4, which gives me negative 20. And then we always write our answer, like I said, as an ordered pair, x comma y. So I got 6 comma negative 20. If you ever want to check your answer, if you have time on a test or a quiz and you want to make sure you did it right, okay, what you should do, you guys, is take your answer and plug it into both equations and make sure it works out. So you do 5 times 6 plus negative 20. Does that equal 10? That's your question to yourself. Well, this is 30. 30 minus 20, is that 10? Yes, so that works out. Then you would move on to your other one. You got to make sure you check both of them. Plug in x and y in. So this would be 24 minus 20. Does that equal 4? Yes, it does. So it confirms that my answer is correct. Okay. Then sometimes we have problems that I have listed here that occur. Okay. Right away, I'm like, oh, this is nice. My x's would cancel. Some of you might even see that the y's would cancel. So I add the two together. Okay. This cancels, the x's cancel, and the y's cancel. So on my left-hand side of my equation, I have nothing left. This is 0. There is no x's, there is no y's, there's 0. And it is equal to 5 plus 7, which is 12. Is this a true statement? Does 0 equal 12? No, that is not true. 0 does not equal 12, so it's not true. And since it is not true, you would say to yourself, that can never be true. That means my answer is a no solution. So if something like that occurs, you get a no solution. Okay. I move on to my next example. I'm asked to solve it. Right away I look and I'm like, darn it, nothing cancels. So I take, and I'm going to eliminate, let's see, they're roughly the same. I'm going to take the top one times 2, negative 2, to get my x's to cancel. So I'd have negative 6x plus 2y equals negative 10. Then the bottom, I'm just going to rewrite that equation. And now when I add them together, x's cancel, y's cancel. On the left-hand side, I have 0. Negative 10 plus 10 is 0. Does 0 equal 0? Yes, this is always true. And since it's always true, what this tells me is there are infinitely many solutions. And what we can do to kind of abbreviate is IMS. Okay, there are infinitely many solutions in this case. So if you come across a statement where 0 equals some number, that's not true. That's a no solution. If you get 0 equals 0 or 5 equals 5 or something like that, that is always true. So it's infinitely many solutions. So graphically, what is going on? Okay, we've had 3 types of answers. We've had infinitely many, we have had no solution, and then we have had one solution. Okay, all of our problems that we started out solving looks like the middle graph. Okay, when they intersect at one point, okay, this was my answer I was getting in my first 3 examples. X, Y. There is one solution. The lines intersect graphically. Okay. So wherever the lines intersect, that's how many solutions there are. So if I go over to the left-hand side, or example A, do these two lines ever intersect? They will never intersect. So that's why it's a no solution. And graphically, we have parallel lines. And then the last option is our two lines are exactly the same line, actually. If you notice, I could take this one and divide it by 2. And I get x plus y equals 1. So these are the same thing. So if you graph the same line on top of the same line, how many times do they intersect? Everywhere. They intersect all the time. So there are infinitely many solutions. You can write IMS, infinitely many solutions. And what is happening there is you have the same lines. They are graphed on top of each other. Okay. So there are graphically what is going on. Then we have to go ahead and solve a few systems with 3 variables. Okay. So the way I'm going to tackle this is I'm first of all going to label my 3 equations. Equation 1, 2, and 3. Okay. What you will do is you will take and eliminate one variable. Okay. So you'll pal up, for instance, you could take these 2 equations and eliminate a variable, and then you'll continue eliminating that variable from 2 and 3. It doesn't matter which variable, try and pick one that looks a little bit easier maybe to eliminate. So maybe the x values or the y values or the z values all kind of look the same already. So in this case, my x's look like there's 2 2's here and then a 1. So that's pretty easy to work with. So I am going to eliminate x. Okay. You could choose to eliminate a different variable. It just might require a little bit more work. Okay, so what I'm going to do is I'm going to take my first 2 equations, equation 1 and 2, and I'm going to eliminate x from them. What will I have to do is I'm going to take equation 1 times -2. So my equation 1, multiplying it by -2 times a -2, and here's what I'll get. I will get -2x minus 4y minus 2z equals -20. My second equation, so it says multiplying by 2, my second equation I'm just going to leave as is. So I got 2x minus y plus 3z equals -5. And I'm eliminating x's, so I'm going to go ahead and add the 2 together. So my x's are gone. I have -5y plus z equals -25. Okay. So now that I have done that, I have a system, or I have an equation with 2 variables. So I'm going to go back to my original set and eliminate x from another 2 equations. So I did 1 and 2. Now I'm going to do 2 and 3. And from equation 2 and 3, I am going to eliminate x. Okay. So if I want to eliminate x, I'm going to take equation 2 times -1. So take it times -1. So I have -2x plus y minus 3z equals 5. Then I'm taking my equation 3 as is. So I have 2x minus 3y minus 5z, and that equals 27. Then we go ahead and add those 2 together. The x's are canceled. I am left with -2y minus 8z equals 32. Now that I have eliminated x from both of these, I have a system of 2 equations. I've created a new system. So I'm going to take my new system and solve for y and z just as I had in the earlier examples. It's a system of 2 equations. Okay. So I'm going to write it right here. I got -5y plus z equals -25. And I have -2y minus 8z equals 32. Now, let's see. I'm going to eliminate z. Okay, it looks like easiest if I eliminate z. I'm going to take the top equation in order to eliminate z, I need it to be a positive 8, so taking it times 8. So let's see, I got negative 40y plus 8z equals negative 200, I believe. And then I have negative 2y minus 8z equals 32. My z's cancel, so I got negative 42y equals negative 168. Just gonna double check. Yep, we got negative 168, and then we're going to divide that by negative 42. And we get y is equal to 4. Once you get one variable solved, you just need to work your way back up. Okay, so now I'm going to go back to my system of 2 equations and solve for z. Once I have y and z, I go back to my original system and I solve for x. Okay, so I have y, so I'm plugging it in. Let's go to the top equation. I got negative 5 times 4. Plus z equals negative 25. So this is negative 20 plus z equals negative 25. And if I add 20 to the other side, I get z is equal to negative 5. Now I got z and y. I'm going to my original. One of the originals, it doesn't matter which one, to solve for x. I'm going to take the top one. So I get x plus 2 times y, so 2 times 4, plus my z, negative 5 equals 10. This would be 8 minus 5, so 3, equals 10. So x is equal to 7. Okay, and finally, I would write my answer as an ordered triple. It's x, comma, y, comma, z. So my x value is 7, my y value is 4, and my z value is negative 5. So there is example 4. If you are working through the homework and you get stumped on one of these and it's not panning out, please do not erase. Either come and see me in person. If that's not possible, take a picture and send it to me. I can look through your work and try and find your mistake for you, okay? Or you can try and backtrack. But don't erase, because usually it's just like a negative sign or something silly that you forgot to do. Okay, so there is example 4. Then we have one last example. All right, as you get to the your turn problem, I would like for you to pause the video and go ahead and give it a try. If you pause the video and come back, I will work through it, but I would recommend you try it on your own first. So hopefully you paused the video and you came back. If you tried it on your own and you got 2, 3, negative 1, nice job, you got the right answer. If not, I'm going to go ahead and work through example 5 now. So the first things I would do is figure out which variable looks the easiest to eliminate. What you see might be different than me. I see there's a lot of 1s with my y's, so I think I'm going to eliminate y's. Okay, so equation 1, 2, and 3. Okay, I am going to start out with equation 1 and 2. And I'm going to, remember, eliminate y's. Eliminate. Yeah, it's supposed to say eliminate. Eliminate y. So I'm going to take the top equation times negative. Nope, it already is negative. I'm going to take it times 4. So I have 8x minus 4y plus 12z equals negative 8. Then I'm going to rewrite equation 2, and it's going to stay exactly as is. So I have x plus 4y minus 2z equals 16. Now I'll go ahead and add the two together. I will have 9x, those cancel, and then I have plus 10z equals 8. So that's my first equation for my system of 2 equations. Now I'm going to move on, okay? I am going to, you can stick with using equation 2 and 3 if you like to kind of keep that process. However, I used 1 and 2. I could also go ahead and use 1 and 3 together. The reason I might use 1 and 3 is if I add 1 and 3 together right now, as is, they will cancel my y's. So I'm going to rewrite equation 1 and equation 3. And now I go ahead and add them together. So So I get 7x, my y's cancel, plus 2z equals 2. Now I have a system of two equations with x's and z's in it. So I'm going to rewrite those. I have 9x plus 10z equals 8. Then I have 7x plus 2z equals 2. So who do I want to eliminate? I would have to multiply this one by 7 and this one by 9 in order to eliminate my x's. So z's actually might be easier. This is a 10 and this is 2, so I can make 2 be a negative 10 by taking this equation times negative 5. So I have 9x plus 10z equals 8. Then I have negative 35x minus 10z equals negative 10. Then I would add the two together. And the z's will cancel. And this will leave me with negative 26x equals I see my mistake. I miswrote equation 3. Hopefully you caught that. So that should be a 14. And then this should be 12. If I follow this through, that should make this a 12. When I take that times a negative 5, that's a negative 60. And then I would have negative 52. There we go. If I divide by negative 26, I would have x is equal to 2. There's the first one. Okay, so silly things like that happen. If you get going too fast, clearly I was. So just be careful of that. Now that I have x equals 2, I'm going to go ahead and go back to one of my two originals. I'm going to go to the top one. So I have 9 times 2 plus 10z equals 8. So I got 18 here plus 10z equals 8. I would subtract 18, so I get negative 10, so z equals negative 1. Now that I have x and z, I need to go back to my original and plug them both in, any one of the originals, and solve for y. I'm going to go bottom one. So 5 times my x, which is 2, plus my y, minus my z, which is negative 1, equals 14. So this is 10 plus 1, so I have 11. So y is equal to, when I subtract 11, 3. And then I can write my final answer as an ordered pair, x, y, and z. So there is example 5, or the your turn problem. If you have questions, feel free to message me. Otherwise, I will talk to you later, and have a good day.